Stars have a life cycle. While stars are not what you might call alive, astronomers and scientists refer to stars being born, living hot and bright, and then dying. Most stars start out the same way, but their mass will determine how long they live for and how they die. Let us take a look at how stars are born. In the beginning of our universe, there was only darkness. Immediately after the Big Bang, the universe was like a hot soup of particles protons, neutrons, and electrons. When the universe began to cool, protons and neutrons combined to make charged atoms of hydrogen and helium. This was a cold, dark fog of hydrogen and helium atoms, better known as the cosmic dark age. The first stars, known as population 3 stars, are believed to have brought light to the universe and ended the cosmic dark age. Astronomers have not directly observed any population 3 stars. However, they are hypothesized to have existed in the early universe. Similar to how stars are born today, population 3 stars formed in clouds of cosmic dust. Turbulence, or violent movements, inside the clouds of dust create clumps of matter that build on themselves, like packing snow together to make snowballs. Once these clumps get to a big enough size, the force of gravity pulls in even more matter from their surrounding space and compacts the clump into a hot, dense core. Astronomers study nebulas like the Tarantula Nebula, as shown here from Chandra X-ray Observatory and James Webb Space Telescope working together to try to understand how stars were formed in the early universe. The chemical composition of the Tarantula Nebula is similar to the early universe. The big difference between the population 3 stars and stars formed today, which are called population 1 stars, is how much metal is in their core. In the early universe, when population 3 stars were formed, the only elements available after the Big Bang were hydrogen and helium and a sprinkling of lithium. Population 3 stars were very low metal content stars. Population 3 stars are hypothesized to be supermassive stars that were very luminous or bright and had relatively short lifetimes as compared to population 1 stars forming today. At the end of their short lifetimes, it's proposed that population 1 stars violently exploded like supernovas today and spread their remnants of hydrogen, helium, and heavier metals in their cores throughout the universe. The oldest observed stars in our universe, called population 2 stars, have a low metal content. Primarily, they are made of hydrogen and helium, but they do have some heavier elements that were created in the cores of population 3 stars. Population 2 stars are born of the remnants of population 3 stars. Basically, the oldest stars we can observe are the phoenixes that rose from the ashes of population 3 stars. One of the oldest known stars, Earendel, is a population 2 star and is about 28 billion light years from Earth. Generally, population 2 stars are found at a galaxy's bulge, the center, or at the halo, the outer edge. Young stars, those that have been forming for the last 1 billion years, are called population 1 stars. By comparison to earlier stars, population 1 stars have a high metal content. Our sun is a population 1 star. It is made of about 90% hydrogen, 9% helium, and 1% heavier elements. That 1% makes population 1 stars heavy metal content. The 1% is iron, nickel, carbon, and trace amounts of other heavy elements. Remember, astronomers refer to any element heavier than helium as a heavy element. Stars born today are formed in stellar nebulas, or sometimes called stellar nurseries. Stellar nebulas are generally contained within galaxies. The pillars of creation, as shown in this image from the James Webb Space Telescope's near infrared camera, are a famous star formation region within the Eagle Nebula of our Milky Way galaxy. The pillars are semi transparent columns of hot gas and dust. Baby stars are forming inside of these pillars. The bright red orbs in the picture are the newly formed baby stars. These stars have gained enough mass for them to collapse under their own gravity, start to heat up and begin to shine bright. How many bright red orbs can you find in this image of the pillars of creation? When scientists and astronomers view the Eagle Nebula in the X ray band of the electromagnetic spectrum, they can see even more young stars forming. This image of the pillars of creation combines an infrared band image from the James Webb Space Telescope with an X ray band image from the Chandra X ray Observatory. The bright purpley red dots are new stars forming in the Eagle Nebula. Can you see more bright purple red dots in this image than the previous image of the pillars of creation? This shows astronomers are using the right tool for the right job. Newly forming stars glow brighter in the X ray band of the electromagnetic spectrum than in the infrared band. Stellar nurseries exist in galaxies outside of our Milky Way galaxy, too. Nebulas NG 2014 and NG 2020, as shown in this image from NASA's Spitzer telescope, are part of the Large Magellanic Cloud LMC galaxy. The LMC galaxy is a satellite galaxy of our Milky Way galaxy, which makes them our galactic neighbor, only 163,000 light years from Earth. The brightly colored regions of this image are hot, dense gaseous clouds where stars form. These gaseous clouds are made of the remnants of the Big Bang, hydrogen and helium, as well as remnants of previous stars that have exploded. This is where the heavier elements come from. New stars forming now, population 1 stars, will have iron, nickel, carbon, and trace amounts of other heavy elements. Herschel 36, the bright star at the center of this zoomed in image of the Lagoon Nebula taken by the Hubble Space Telescope, is surrounded by dark clouds of gas and dust. This image is a combination of two images taken by Hubble. One is in the visible band, and one is in the infrared bands of the electromagnetic spectrum. The clouds of gas and dust are cold on their interiors, which is the dark gray black areas of the clouds, and hot exteriors, which are the brightly colored in this picture. Over time, these clouds will collapse from their supermass and give birth to the next generation of stars. Essentially, the scientists at NASA overlaid the two images taken by Hubble to create this one image. The visible band portion of the image shows the gaseous clouds, and the infrared image can peek through the gaseous clouds to find the young stars hiding inside the dust.